All right, in this video, we are going to look at our absolute value equations and our absolute value inequalities. So right here, these top two examples are just going to be absolute value equations. We just have equal sign, right? So absolute value equations. If you remember our steps, our very first step with absolute value anything, absolute value, we have to isolate the bars. This first example, the bars are already isolated on the left-hand side, which is nice. When the bars are isolated, remember to check. The right-hand side number has to be a positive. In this case, it is, so we are good to go. If this was a negative 54, we would stop right now and say there's no solutions. But since it's positive, we're good to go. Absolute value, we have to have two equations. The first equation, we just get rid of our bars. 9a equals 54. And we'll solve that one here in a second. But I want to write both equations. The second equation, 9a equals, the only thing that changes is the right-hand side changes to a negative 54. And we will solve that one. This should be pretty easy to solve for a. We divide by 9 on both sides, and I get a equals, what's 54 divided by 9? 6? I'm not very good at math. On the other one, we'll solve this one for a as well. Divide by 9 on both sides, and we get a equals negative 54 divided by 9, negative 6. So we get two solutions there. There's nothing to graph here. There's no graph since we just have equations. We're just figuring out what does our variable equal. There's no graphing. There's no shading on these. Just figuring out what our variable equals. Number two, I can't do anything with this one until the bars are isolated. I always want to divide last, so don't tell me divide by 6 right off the bat. No, we divide last. The first thing we need to do is we need to subtract this 1 from both sides. So I've got 6, absolute value 10 minus 2r equals 13 minus 1 gives me a 12. I need to continue to isolate the bars. Since the 6 is attached to the bars, I will divide by 6 on both sides. So now I've got absolute value of 10 minus 2r equals 12 divided by 6. That's 2. Now that the bars are isolated, I need to make sure the right-hand number is positive. In this case, it is, so we are good to go. If this 2 was a negative right here, you would stop right now and you'd say no solutions. So from this point on, don't go back. From this point on, we write our two equations. The first equation, we just get rid of our bars and nothing changes. 10 minus 2r equals 2. And I'll solve that one here in a second. The second equation, the only thing that changes is the number on the right. So we got 10 minus 2r again, but this time it equals a negative 2. All right, so we're going to solve each one of these, and we're going to get two answers for r. We're going to subtract 10 first. Negative 2r still on the left. 2 minus 10 gives us negative 8. Then we're going to divide by negative 2. Divide by negative 2. R equals, if this was an inequality, I would have to flip the sign, but since it's an equal, there's no flipping equal signs. Negative 8 divided by negative 2 is positive 4. So there's one answer. And we're going to come over here to the other side, and we're going to do the same steps. We're going to subtract 10 to both sides, so we can solve this one for r. Negative 2r equals negative 2 minus 10 more gives us negative 12. And then we're going to divide by negative 2 to get that r by itself. And I get r equals negative divided by negative, positive. 12 divided by 2 is positive 6. So there are the two solutions there. Absolute value equations. You're just going to come up with your two solutions solving for your variables. You need to have two equations. Make sure you isolate your bars first. Now moving on to absolute value inequalities. Again, make sure your bars are isolated. Absolute value of x minus 9 is less than 1. Yes, the bars are isolated. Good. Now, we have a less than. Less. Remember the notes we took in class today. And. This is an and problem. So I've got x minus 9 is less than 1. If it's an and problem, the x needs to be in the middle. So I need another less than on the other side. And if that's a positive 1 on the right, we got to put a negative 1 on the left. And we will solve for x. In this case, get x by itself, we're going to add 9 in the middle section. But if we add 9 in the middle, we got to add 9 on all sections. Negative 1 plus 9, that gives me 8. We don't flip our sign because we didn't divide by a negative. Signs stay the same. And on the right, positive 1 plus 9 gives me 10. All right, so my smaller number 8 is on the left, which I want. My bigger number 10 is on the right, which is what I want. So it's set up the right way. I'm ready to graph this. The two numbers I'm circling are 8 and 10. Neither one of them have the equal to on it, so neither one of these guys are going to be shaded. But I do need to shade either outside or in the middle. Since this is an and my x is in the middle of my two numbers, I will shade in the middle of my two numbers. So when we ask for interval notation, what did we shade? We shaded from 8 to 10. So we say 8, 10, and since both the 8 and the 10 are open circles, then both 8 and 10 get parentheses. There's one section of shading, that's it. So we just have one section of the interval here. All right, on the second example, I'm going to change this to be a greater than. Okay, we're going to use it as a greater than just so I can show you another example. All right, so remember, greater than, we treat it as an or problem. Well, I can't do anything until the bars are isolated. I'm going to rewrite it down here. 7 minus 2r, we're using greater than 58. Okay, I've got to isolate the bars. I don't want to do 2 plus 8. If that said 2 plus 8x, how would you get rid of the 2? We got to subtract 2. We divide at the end. So we're going to subtract 2 from both sides. The 8 is still attached to the bars. Let's see, if we subtract 2 over here on the right, 58 minus 2 gives me 56. Now we still got to get rid of our bars, so we're going to divide by 8 since he's attached. So now I've got absolute value, 7 minus 2r. I divided by positive 8, so the sign doesn't flip. 56 divided by 8 is 7. Once the bars are isolated, we look to see what we've got. We've got a greater than, or. That's an or. I need two separate equations. 7 minus 2r is greater than 7. That doesn't change. Or the second equation, we still have 7 minus 2r. The second equation, two things change here. The greater than changes to a less than. My positive 7 on the right changes to a negative 7 on the right. And now I can solve each one individually since this is an or. We will subtract 7. So I've got negative 2r is greater than 7 minus 7 is 0. Divide by negative 2. Divide by negative 2. When you divide by a negative, the sign flips. 0 divided by negative 2 is 0. Okay? Flip your inequality sign from a greater than to a less than here. All right, now let's work the other one. Solve this one for r. Same steps. We're going to subtract 7. Negative 2r is less than negative 7 minus 7 more. That's negative 14. Now we're going to divide by negative 2 on both sides. When you divide by negative, your sign flips. Alarms go off. Negative 14 divided by negative 2. Negative divided by negative, positive 7. So the two numbers I'm circling here are 0 and positive 7. 0 and positive 7. Now, neither one of them have the equal to underlined, so neither one of them are going to be filled in. So it's an or. I should already know what it's going to look like. We should shade outwards, but let's just double check. I need to shade all my r values that are less than 0. So we shade to the left of 0. And to the left of 0 forever is negative infinity. Now this one, we shade all the values that are greater than 7. So here we shade to the right. Everything greater than 7 and forever to the right would be positive infinity. So if we were going to write this in interval notation, we're going to have two sections of shading. The first section went from negative infinity to 0. Infinity always gets parentheses, and 0's an open circle, so 0's also going to get a parenthesis. But wait, there's more. So we use our little union symbol. Where's the next section that we shaded? Well, the next section went from 7 to positive infinity. 7's an open circle, so he gets parentheses, and positive infinity. Infinity always gets parentheses. So that would be our interval notation there.